Hold on. Thought I'd do something different today. What the? Did you just pull my character model? Video game development is both the most complicated and most enjoyable medium of entertainment out there. It's a constant fusion of art and science. Working on a game alone, the topic of my work ebbs and flows between these two disciplines, and for the past 3 months, I've been hard at work on the science to make the art much easier. I've created an adaptable script which automates the creation of any sort of object in my game. It builds all necessary components and automates the setup of animations. This streamlines development, allowing me to quickly import any new object, easily adjust the system from a global perspective, and keep the codebase of any object in my mind. Events themselves are streamlined in a similar way. I've created a controller subscript on these objects which handles any and all calls to the object. You can consider calls to be a way of altering the data on the object, so an animation, movement, or attack must be filtered through a call. These calls are filtered out in the same structure no matter the call. Call, handle, fire. The call check filters out technical constraints, the handle filters out conditional constraints, and the fire triggers the event. I developed the events this way to allow me to create a replay system, which you can see functioning here. All calls are stored into JSON, and this JSON can be reassembled and used to recreate any scenario. My primary reason for making this system was to test my code, to make sure I had a strong foundation, but it's proven to be far more useful than I first thought. It's useful for debugging through recreating edge cases, simulating combat encounters, and a few other tricks that I won't reveal here. I could go over all these systems in more detail, but for now I want to dial time back to 3 months ago to answer the question, why does my game need these systems? Using my Git repository, we can look back 3 months ago and examine my code at the time. The major issue with my code was that each object had its own class. You can think of these classes as a brain for the object. Comparing these two brains side by side, you can see that the code isn't symmetrical. They run on two entirely independent systems. While these scripts do inherit some of the base class, they diverge from the parents so much so that they lose all sense of cohesion. The way they attack, move, and interact with the world is unique, meaning each script needs contextual code for interacting with any other object in the game. Here's an example of that. The player can fire a blast of air which is meant to push back all objects. In this method, I'm handling each type of object that we might try to blow back. Notice that AI isn't even listed here, we would need another case for that. For every new object, we need a new case, and for every new action, we'd need a new method. Now, this isn't necessarily a bad system. Many games handle interactions this way, creating custom code for each scenario. It's slightly more laborious, but if your game handles simple systems, then it's still manageable for the project scope. Moreover, pivoting to a new system isn't a simple task, it involves rewriting all code. So if you can get away with the systems you have, then there's little reason to change. Before taking this big leap myself, I had to assess why my game would benefit from a more adaptable system. Let's take a look at Life is Strange, for example. Your interaction with the world prompts some narrative progression, but it very rarely has physical repercussions. The objects in the world don't interact with each other. An NPC can't pick up a rock and throw it, and a rock can't shatter the window. Any situation where this does happen in the game is almost certainly a scripted sequence in which hardly any game code is processing the action. Instead, some animator is putting the scene together. If I were to pitch my system to these devs, they would be justified in turning me down. A narrative game like Life is Strange doesn't need an adaptable system for objects because the interactions in the game world are fairly straightforward, and there are no interweaving systems that require communication between varied game objects. Instead, the majority of the code involves the manipulation of narrative text and plot details. If there was a system needed in Life is Strange, it would be some system to organize the branching storylines, not an adaptable system for the game objects. Imagine now though that I was working on Skyrim, a game where the player has a wide variety of ways to interact with the world, the most iconic being the Dragonborn's first shout.
What's that?
Notice that this shout isn't just affecting the enemy, it's also pushing objects around it. In a general sense, we could say that the player's actions have the potential to affect any sort of game object. The action is dynamic too. The effect of the action isn't the same across all objects. The enemy is forced into a hurt state, allies are angered, loose objects are sent flying, and static objects remain in place. Using my straightforward method, we would need to handle each one of these in an if-else chain. The more objects we add, the more convoluted this becomes. The code would inevitably bloat past the point of comprehension. If I'm making a game in which dynamic actions are plentiful, then it makes sense to have an adaptable system which can handle a multitude of varied objects. So instead of requiring contextual code for the enemy, allies, objects, static objects, we could instead have one adaptable system which obfuscates the overhead of any action. If I want to have an immersive action game with interweaving systems, then I need a streamlined system to manage the interactions of diverse objects. At the top of this, I mentioned how I wanted the player to be able to fire a blast of air which could push back all objects. I was able to recognize though that my codebase needed to be reworked if I wanted to have dynamic actions like this. Now with all of that work done, here is the one line of code required to do that same functionality with my new system. But let's talk about structure. How do you craft a systemic game? Because I'm kind of lying when I say it's one line of code, and that belies just how complex of a system is at play to make this happen so easily. Under the hood, there's a rabbit hole of code that makes a simple method call perform a multitude of complex actions. What's important here is that I'm not hacking together some monstrosity of code and then tucking it under. Since it all gets covered up, it's tempting to just hide the monster under the bed, but I need to have a strong foundation for these systems. So from the outset, your goal must be to create an orderly and well-commented system that can be easily maintained over a long period of time. There are two methods to achieving this. Thoughtfully craft a plan beforehand, or hack together spaghetti code to get a working prototype running. I always choose the latter option. I think it's because I'm still a novice programmer, but I just can't theorize how a system should work beforehand. I have to make it first and then work backwards. It's more work in the long run, but it's the only way I can make a good system. Once you've made your spaghetti monster, it's time to delete the entire beast and begin again from scratch with structure in mind. From here, work to organize and comment your code. For me, I try to write my code so that a non-programmer could understand it. That's overkill at times, but it always ensures that my code is readable. Once I'm finished, what's important is that all the functionality is obfuscated, meaning this script, the player, doesn't have to worry about what any object might do with the information. And more importantly, I don't have to worry either, because I have a streamlined system for processing any incoming data. Call, handle, fire. In my opinion, this streamlining should be the goal of any systems designer. To craft a systemic game, you need a strong foundation to build upon, rigid rules for consistency, and a simple-to-use system once all the setup is done. If you're overwhelmed with all this technical jargon, I truly am sorry, but I promise my next devlog will be far more focused on art and game design. The reason for that is because my last topic for this video is streamlining my art pipeline. Thanks to all the tooling I've done, importing art into my game is seamless and nearly instantaneous. So let's talk about the importance of tooling, and what is a technical artist? While the necessity to have a systemic mechanic may be up for debate, the tools that I made for automation are far more objectively necessary. If you are making a game, I'd highly recommend investing time into the role of technical artist, whether that means bringing someone else on or working on it yourself. The name technical artist is a bit misleading as you won't be making any art. Instead, you will be creating the tools to streamline the work for the artist. Since all objects would have the same base code, I had the inspiration to automate the process of importing objects and setting up their structure. If each object would function with the same code, then I figured I could set them all up in the same way with some parameters to differentiate the objects. I'd be lying if I said I understood just how challenging that would be when I started, but it was certainly easier with the foundation of my adaptable objects. I won't try to bore you with the details, and instead I'll try to amaze you with the concepts. So let me make an analogy that I think we can all understand. The process of setting up any given object used to take me anywhere from 30 minutes to an hour, but now I can set up all 3 objects in less than 5 minutes. I'm achieving this through an automated animation setup, a blueprint animator that can be overridden during runtime, and a builder script which adds all necessary components, classes, and references. Again, the structure is streamlined with this chunk of code being the designation for all building, and all of these methods have the same order to them. That pretty much sums up all the systems I've been working on for the past 3 months. I was going to talk about optimizations too, but honestly, this video is already too long for my taste, and I just want to get back to working on the game.